Hello, in this video we will do a AOPS homework intermediate counting problem. So, uh, here's the problem. In how many ways can we seat three pairs of siblings in a row of 7 chairs so that nobody sits next to their sibling? One chair will be left empty, of course. Okay, so we have this condition, and since it says no, nobody sits, that suggests, complementary counting. So let me actually switch to my scratch paper. Uh, so the total number of ways to arrange them is 7 factorial because you have 7 ways to choose the empty chair and then 6 factorial to arrange the rest of them. And this is just 5040. And then we use pi or principle of inclusion exclusion. So if you have one pair, let's suppose A1 and A2 are together, then we have B1, B2, C1, C2, and then an empty chair. So if we think of these two as one singular block, you have 1, 2, 3, 4, 5, and the empty chair. So that's 6 entities to arrange. And then for the A1, A2, you have 2 factorial ways to arrange A1 and A2 inside of their block, right? And this is 1440. And this applies to if B1 and B2 are together, and it applies to C1 and C2 are together. So we actually have to multiply 3 times this. So that's 4,320. Now we have to subtract the cases where 2 pairs are together. So without loss of generality, assume A1, A2 are together, B1, B2 are together, and then we have C1, C2, and the empty. So this is 1, 2, 3, 4, 5 entities, so 5 factorial. Then you have 2 ways to arrange A1, A2, and 2 ways to arrange B1, B2. And this gives 480, and then times 3, so 1440. And then next is if all 3 pairs are together. Oh, yeah. So A1 and A2 are together, B1 and B2 are together, C1 and C2 are together, and then you have an empty chair. So there's 4 entities. So to arrange those, you have 4 factorial ways times 2 factorial here, 2 factorial here, 2 factorial here. So 2 factorial to the 3rd power. So this is 24, this is 8, 160 plus 32 is 192. So by principle inclusion exclusion, our total number of ways for 2 pairs to sit next to each other is this minus 1440 plus 192. So this is what 2,880, 2,980, and then 3,072. So this is 3,072. However, this is not the answer because we have to subtract this off from 5,040. So this gives what? This gives 1,968. Okay, let's see if I was correct. And yes, I was correct. Bye bye.